So for this one, we have f of 1 means the function value at 1. So you go to 1. Here's x equals 1.
Mhm.
So where does it touch that line?
1.
It's right here. So it's 1. So f of 1 is 1. The limit as x goes to 3 of the function means jump on the function just before and just after 3. So 1, 2, 3. So here I'm jumping on the function just before 3 and I'm going toward it.
Mhm.
What would you expect the value to be as you get closer to it?
1.
You expect it to be 1 because from the right and the left, doesn't matter which side you're coming from, the expected value is the same, which is 1.
Mhm.
The limit as x goes to 1 from the left means jump on the graph just left of 1, which would be all the way up here, right?
Yep.
And go toward 1. And what would you expect the value to be?
1, 2,
One.
3, 4, 5, 7.
7. So 7 is the limit from the left. And the limit from the right, jump on the graph just to the right. What would you expect it to be?
1.
You'd expect it to be
Oh,
that right there,
that's
4.
that. Okay. 4.
right? That's what you would expect it to be. The function value is itself is 1, but you wouldn't expect that. If you were on the graph on the right, you would expect the value to be 4. If you were on the graph to the left, you'd expect the value to be 7, and therefore the limit does not exist at 1 because it's different from the right and the left.
Yep.
Make sense?
Yeah.
All right. On the reference angle for 2, 5, 6, that would mean jump on your graph. 256 is all the way over. Let's see, what quadrant is it in? Here's 180. That's 180. Plus 90 is 2. 180 plus 90 is 270, right?
I actually don't need to do that one. I was just trying because you just add 360 and subtract 360, right? For that.
No. Nope. Nope.
That's no.
Nope.
Oh, okay.
Not necessarily. That's coterminal angles. Reference angle is you draw the angle and then they want this angle right here. That angle right there. So it's 256 minus 180 in this case.
Why is that minus 180?
Because look at the graph. It would be this angle. The reference angle is the acute right angle, 90-degree or acute right angle that is made with the x-axis. So your reference angle is 76. If you were in this quadrant, you would subtract it from 180. If you were in this quadrant, you would subtract it from 360. And if you were in this quadrant, it's just whatever that angle is. But if it went all the way around like this, you'd subtract it from 360. So reference angles are a little different. You don't always do the same thing.
Okay.
That makes sense? So the reference angle of 13 pi over 8. So I like to think of it like this. Here's pi over pi. This is 8 pi over 8 right here because that's 1 pi, right?
Yeah.
So 13 pi over 8 is going to be and this is 12 pi over 8 because it's another quarter, right? It's another quarter of or half of no, that's another half of the pi. So whoops, I wrote 4, I meant 8. Another, so this would be pi, 4 pi over 8. That's 8 pi over 8, that's 12 pi over 8. So 13 pi over 8 would be all the way right here. You got it? Which means your reference angle is this angle right here. And what would that be? This is 13 pi over 8. Then what would that be? Remember, this is 16 pi. That's 16 pi over 8.
So pi over 2. Would it be 16 pi over 8 minus 12 pi over 8?
No, you don't subtract it from 12. You subtract it from 16.
Or
It's this distance right here.
so 3 pi over 8?
Yep, 3 pi over 8.
Yeah.
So your reference angle for this is 3 pi over 8.
Mhm.
So every one of those is a little bit different. Coterminal, that's easy. That's where you just add or subtract
Yeah.
360 as many times as you need to. So you can do number 3. Give the value of the secant of 7 pi over 4. Well, that's just 1 over the cosine of 7 pi over 4. And the cosine 7 pi over 4, look at your unit circle. You good with that?
Yeah.
7 pi over 4 is going to be negative root 2 over 2.
Yeah, I'm just like having trouble like remembering like what's what, so that's why I like kind of took a picture of this.
Yeah. So let's see, is that right? Is it negative or positive cosine? Cosine is 7 pi over 4. What quadrant is 7 pi over 4 in? Again, I just think of adding. Here's 1, 2, 3, 4, 5, 6, 7. It's in the fourth quadrant.
Yeah.
So the cosine is positive.
So
right? So this is 1 over root 2. So it's just root 2.
Yep.
The cotangent is 1 over the tangent, and 11 pi over 6 is just short of 12 pi over 6, which is 1 full revolution. So 11 pi over 6 is right here. So the cotangent in that quadrant is going to be negative, and it's going to be it'll be negative root 3. Right? Because it's the flip of the tangent, and the tangent there is negative 1 over root 3. The tangent of 3 pi is just go around it. It's just right back to here. Because here's 1, 2, 3. So here's 3 pi. So the tangent of that is sine over the cosine. The sine is 0. The cosine is negative 1. So it's just 0.
Okay.
Determinant quadrant lies in this. The cosine is positive. So cosine positive means it's 1 or 4. And the sine is negative means it's in the 4. Got it?
So if it's like greater than, that just means positive?
Yes. And this is your x value and this is your y value. So remember, if you look at your unit circle, it's positive, positive. This is negative, positive. This is negative, negative. And this is positive, negative.
Makes sense.
Okay. If that point is on the terminal side of O, find the following. So this is where you would draw it. You would draw it out. 1, 2, 1, 2, 3, 4, 5. So there's your point. So this distance is 2. This distance is negative 5. So the 2 squared plus negative 5 squared equals c squared, right? Pythagorean theorem. 4 plus 25. So this is 29, root 29. So the sine is opposite over hypotenuse, negative 5 over root 29.
Yep.
Got it, I'm doing that. Cosecant is the reciprocal of the sine, so it's just negative root 29 over 5.
Yep.
Good?
Yep. And then I gotta find that real quick. Oh,
that's where number 9.
Yeah.
If the tangent is negative 3 over 7 and the cosecant is negative, find the secant. So again, draw it out. They're saying the cosecant is positive. Sorry if I said negative. The cosecant is positive. That means the sine is also positive, right? So the sine is positive means it's in 1 or 2. And if the tangent's negative, that means it's in 2. So we know it's in this quadrant 2. So let's draw it in. This is your opposite. This is your adjacent. So opposite, adjacent. The opposite of that angle is going up, so it's a positive. Oops, so that's a positive 3. The adjacent is that one, so it's a negative 7. Got it?
Yep.
And so this is 3 squared plus 7 squared equals c squared. So 49 plus 9. So that's 58 sorry, 58, right? So square root of 58. Find the secant. So the secant is the secant is the hypotenuse over the secant is cosine, so adjacent. Hypotenuse, so root 58 over -7. Got it?
Yep.
Identify a point on the unit circle on the terminal side of theta given. Okay, so just what's the point basically at 2 pi over 3? So here's 1 pi over 3. That's 60. Here's 2 pi over 3. So that point is negative something, positive something. It's -1/2 positive root 3 over 2.
Yeah.
40-foot ladder leans against the side of the building. Calculate the distance. You good with these?
Yeah, I'm fine with that. I was just the first two.
Okay. I'm just trying to get through it. I don't know how many you put on there. It looks like you put a lot, so I'm just trying to get through all. Solve the triangle. So draw this out. They're giving you A, so this you can use law of sines. So the sine, I don't really even have to draw it out. The sine of 54 is to 42 as the sine of 17 is to B. So solve,
yeah.
cross multiply, solve, right?
Yeah.
So B equals 42 sine of 17 all over sine of 54.
Yeah, and then I forget. So I know one of them in this situation you do like the inverse when you divide it, and then one of them you don't. So
yeah, if it was the angle you were going for, you do the inverse.
Okay, let me just write that.
So now number 32 is a different. Number 32 is a different kind of problem. This is the ambiguous case, I think.
Yeah.
Because you've got an angle and you've got A and B. So I always like to draw it like this. So here's my 83. There's my 83 degrees. And then I don't know C. So, actually, no, this might be just law of cosines. I know A and B, and it's the included angle, side angle, side.
Yeah, side angle side is an ambiguous case, right?
Yeah, this is side angle side. So actually, this is not the ambiguous case. The ambiguous case is angle side side.
Oh, okay.
But we have a side, an angle in between them, and another side.
Yeah, isn't that law of cosines?
Yeah, this is law of cosines. So just plug and chug.
Yeah.
I'm gonna save the skip from doing that. There's the step from doing that, but there's just a formula, right? And you just plug everything in and solve it.
Yeah.
You're good at that, right?
Yeah.
Evaluate the secant of 35 degrees, I assume. Is that degrees?
It doesn't say. It's like
kind of tricky.
It's what's this unit? It was in like trigonomic functions. Or no, it's in graphing trigonomic functions. So I don't know if that helps.
Yeah, so it technically, if they don't have if it should be the degrees, or it should be the radians, but 35 is a big.
I think I can just put that in my calculator, right? Just sign.
Yeah, you can.
Whoops.
Yeah, you can.
We can use the calculator on the final, so I think that should be fine.
Yeah, here I'm grabbing my calculator out for you just to show you. So if just make sure you know what mode you're in, so you can see. On mine, I'm in degrees. So if I punched in secant, I would have to do 1 over the cosine. 1 divided by the cosine of 35. So if it's in degrees, it'd be the secant would be 1.22 roughly.
Yeah.
But if it was in radians, let's see what happens if I put it in radians. And I hit second, enter. Then if it's in radians, then it's approximately -1.10 7.
Yeah.
So it could be that. That could be. I would guess that it's probably that one. The second answer is probably what they want. But just ask your teacher. If they don't have degrees, you probably assume that it's in radians. All right, write a sine and cosine equation for the following graph. So the sine equation would be the easier one, because see how it's starting right here?
Yeah.
And that there's no shift. So let's find all of our values. First of all, here's the midline. So that tells you that your D equals 0. So there's no horizontal, or there's no vertical shift. This being here at 0 means that your C equals 0 for your sine graph. And then this up here going up to 3, that means A equals positive 3 because it's going up. And then A, B, C, D, we just need to know what the period is. So your period is related to, sorry, your B is related to your period. B equals 2 pi divided by the period.
Yeah.
And you can see that your period is, what is that, 1 pi?
Yeah, I think so.
So B equals 2. So my equation is Y equals 3 sine 2x, just 3 sine 2x. That's it.
Okay.
The cosine graph is going to be a little trickier, because for the cosine, I'm going to have to shift it pi over 4. So that means C equals pi over 4. I'm shifting it to the right. Right? So when I write this out, I'm going to have to write cosine, and then I'm going to put a 2 in front, and then in parentheses, I'm going to write x minus pi over 4. I would always put that 2 out front when you're having a horizontal shift. The other shifts are still the same, though. Everything else is the same. It starts up, so it's still a positive 3. And so that's your cosine graph. You could have also shifted it left instead and started here, but then you'd have a negative 3, and this would be a positive. So this could be a negative, and that would be a positive.
Okay.
Got it?
Yep.
This, I'll just do the sine real quick for you. So this, here's your midline. So that tells you that D equals negative, what is that, 2?
Yeah.
D is negative 2. It's a cosine graph, and it's starting at the top, so there's no shift. So C would equal 0 for that cosine graph. And the period, you can really look anywhere for the period. So here's where we can see the period is 2 pi. So B still just equals 1. So your cosine graph would be, oh, and my A is 2. Right?
Yep.
So it is going to be 2 cosine of, I'm not shifting, just 2 cosine x minus 2. Good?
Yep.
Did we ever do these before? You just posted those other ones from on top of the same sheet?
Yeah, those are old ones.
Okay. Do you want to post a couple more questions?
I think here, I think I finished the rest of the packet. Let me look.
You got the rest of it? You want?
Yeah. Yeah, I finished the rest of it.
Okay, nice. So you're good. You don't have you feel like you're pretty good. You need to go over any of the things that we went over. I didn't realize that those other pages were old pages, so I was kind of going fast.
Here, let me look. I mean, I have a cheat sheet too, so it's. I mean, I really don't think I need anything else to go over with. So.
Okay.
All right.
Sounds good. Hey, good luck at Purdue.
Yep. Thank you.
That's awesome. When are you going to orientation anytime soon?
Yeah, I think it's in June.